Good afternoon, everybody. I think this is working. All right. Hopefully this class actually gets recorded properly today. Okay, everybody, I gave you back your tests. If you don't mind right now, let's not go over those quite this second. We'll do that towards the end of class. Okay, guys, listen up. All right, we'll go over those tests at the end of class. Instead, what I want to do now is kind of get to the lesson, make sure we got everything down that we need to get down, so you guys are good for the homework tonight. Okay, we're going to do two things today. All right, and this is going to wrap up our talk about matrices. Okay, basically the first thing we're going to do is we're going to look at the inverse of a 2x2 matrix. Okay, and that's the only one we're going to go over as far as inverses are concerned. The reason for that is inverse for a 2x2 matrix is fairly easy to do. As far as anything beyond that, we're just not going to be that interested. It's not going to be very helpful to what we're up to. Okay? So, inverse of a 2x2 matrix. Alright. So by definition, two matrices are inverses if A times the inverse of A is equal to the inverse of A times A is equal to the identity matrix. Okay? So if I do that, okay, if that holds true, then the matrices are inverses of each other. Okay? To calculate it, if A is equal to the matrix A, B, C, D, then the inverse of A is going to be equal to 1 over the determinant of A times, okay, D minus B minus C A. Okay, so it's this kind of weird getup you get. All right, when you flip one diagonal and you negate the other. Okay, everyone see that?
What's it under the one under?
Oh, determinant of A. So DET A. Let me clean that up a little bit for you guys. Okay. 1 over DA, determinant of A. Okay? Now, any questions here? We're going to do an actual example with real numbers.
You just switch the locations? How do you?
Yeah. Basically, just A and D just flip, and B and C become negative. Okay? So, you flip these guys as positions. So A and D switch places, and B and C flip signs. Okay, that's it. All right? So, let's take a look at an example real fast with actual numbers. Okay? Let's say we've got, let's make our matrix 3, -2, 5, and 4. Okay? First, we need the determinant of that. And that's going to be equal to 3 times 4, which is 12, minus 5 times -2, which is -10. Okay? So 12 minus 10 is equal to 22. I think a few of you on your test, I think I gave that same exact matrix. And a few of you put the wrong answer there. Okay? That's the correct answer. Okay, 22. All right. So then, the inverse is going to be 1 over 22 times 3 and 4 are going to flip, and 5 and -2 are going to change signs. So that's what we should get there, which comes out to be 4 over 22, 2 over 22, -5 over 22, and 3 over 22. Okay? And you can leave it like that. You don't have to simplify the fractions. Okay, so that right there is the inverse of that matrix up there. Any questions? Okay. I'm not going to erase it yet, because what we're going to do next is we're going to check to see if these are inverses of each other. Okay, to make sure we got the right inverse. So what you could expect on a test or quiz involving this, 2 questions you might get. One would be to produce an inverse of a 2x2 matrix. The other one is to check to see if 2 matrices are inverses. And I could give you something more than a 2x2 in that case. Okay? I could give you like 3x3, 4x4. Because then it's just a multiplication thing. You're just seeing if the product is the identity matrix, okay, for that, that group. Okay. All right, let's take a look at it real fast, okay? Here's my check. Check. Basically, 3, -2, 5, 4 times 4 20 seconds, 2 20 seconds, -5 20 seconds, and 3 20 seconds. When I multiply these things together, I need to get 1 0 0 1. Okay? So, what's 3 times 4? 12, right? So we're going to have 12 20 seconds plus -2 times -5. That will be +10 20 seconds. Okay? Then I'm going to do 3 times 2 20 seconds to get 6 20 seconds. And then -2 times 3 to get -6 20 seconds. Okay? Done with this row, and move on to the next one. Do 5 times 4 20 seconds to get 20 seconds. Then do 4 times -5 20 seconds to get -20 20 seconds. And then finally, same thing with the last column, 5 times 2 to get 10 20 seconds. And then 4 times 3 to get +12 20 seconds. Okay? Now, what's 12 plus 10? It's 22. So I get 22 over 22, which is 1. What's 6 minus 6? 0. So I get 0 there. What's 20 minus 20? 0. And what's 10 plus 12? 22. So I get the identity matrix 1 0 0 1 out again. Okay? Any questions there?
So it was like a lot of work just to check this.
Well, yeah, and the
More work to check.
but that's how it comes out to be. Okay. Oh, wasp in the room.
Yeah.
All right. Anybody allergic?
I would.
You are. Yeah. Okay. Well, if you ignore him, he will eventually go away. He'll probably fly out the windows.
Make sure Tommy's allergic.
Tommy, he's not allergic, he just gets really scared.
Alright, don't worry about him, just ignore the wasp. If he bothers you, feel free to squish it. If you need me to squish it for you, I'm more than happy.
We should just kill it.
I am not.
Quick break to smash it.
I'm not allergic to wasps,
Tommy is.
nor am I afraid of them.
It's
Alright,
gonna nest in the wood and you're gonna have.
especially because they were born angry. Alright, any questions about this right here? This is just a check. Okay? All this should be fairly easy to do. All good? Okay. Huh?
You got 1 0 0 1. How
Yeah.
is that the?
That's the identity matrix.
Okay. Yeah.
Remember, the identity matrix are ones where the diagonals are 1 and everything else is a 0. So if these were 2 3 by 3 matrices, I should get a row of ones going, a diagonal of 1s, and then everything else should be a 0. Okay? And if I chose 2 3 by 3 inverse matrices, that would happen. Okay? But that's how you always check. Okay? Now, really, all I did was just to show you how to do the multiplication that it works. To be honest with you, like I said on test for your quiz, you're going to get either this one up here as your question, or this one down here as your question. And remember too, you'll always be allowed to use a calculator to work these things out. So that's a big help. Okay. All right. If there's no further questions here, let's move on, because the next thing is going to take a few minutes to explain, and it's the most important thing that we're going to do today. Okay. So far with matrices, okay, we've learned a lot of operations in matrices, but we haven't, everybody, learned a good use for them yet, okay? And that's what we're going to do right now. Basically, we want to use matrices, okay? We want to use matrices to solve multivariable equations. quick example, what I mean by a multivariable equation, okay? And kind of quickly review as well the earlier methods we used to solve these. So, we'll keep things simple. We'll look at a quick 2x2 multivariable equation. So this might be something like 5x minus 4y equals 2, and x plus y is equal to,
Does it say want to use matrices?
Huh?
Want?
Want to use
I was like,
matrices to solve multivariable equations. We'll make it 6. I don't know, I'm just picking numbers at random. Okay? Let's make this 3x plus y equals 6. Okay. Now, what were the old-fashioned ways I had of solving this?
Substitution and elimination.
We had substitution and elimination. Substitution, we would just, pick a variable, solve for that variable, plug the entire thing back in, get our answer. So if I did this by substitution, I would probably solve for y in the bottom equation first, then plug that in for y in the top equation. Okay, that would give me 5x minus 24 plus 12x equals 2. So, cleaning up everything, that gives me 17x is equal to, 26? So, x is equal to 26 over 17. And then if I wanted y, I would plug this back in for it up here and solve. Okay? Easy peasy, right? No problem there. Okay. By elimination, I do that whole thing where I set the thing up as a giant, addition problem basically, and manipulate equations to get rid of a variable completely. I'll probably get rid of y again because it's singular, so it's easy. So we'd have 5x minus 4y equals 2. I'm going to multiply the bottom equation by by plus 4, excuse me. Because then when I add it to above, the y's will cancel. So it's 3x times 4, it's 12x, plus 4y equals 24. We add these up, those cancel, give me 17x equals 26. So x is equal to 26 over 17. And again, just like before, I would take that answer for x, plug it in to solve for y. Okay? Another way I can solve this is by graphing. I can actually graph these two things as lines and work out my answer that way. Okay? All of those are valid ways to solve this thing. Okay? And they all work about the same. Okay, so matrices then. This isn't that hard to do. Why do I need matrices to do these things? Well, what happens instead of two equations of two unknowns? I had something like this here.
10
okay?
equations of 12 unknowns.
That actually couldn't solve no matter what you do. Too many unknowns. Need more equations.
10 equations of 10 unknowns.
10 equations of 10 unknowns I can totally do. And it would take forever. Unless I use matrices. They won't only take a few minutes.
This is not the whiteboard.
Okay?
How can you read this? I can't.
Hold up, 5x.
Wait, you having trouble reading something, or
No, because I'm handwriting.
my handwriting is bad? Well, yes, but
Lori, don't insult the teacher.
I'm saying, you're handwriting. Lori, just because we're all maggots,
no, my handwriting is terrible. I
I think it's pretty good.
Okay.
Need a board, man.
Trust me, there's a lot worse.
I'm gonna start taking back.
I know. I've gotten slightly better as I got older,
Gotta take it back.
but not much. Anyway, here's our next problem here. Now, how many equations do I have? 4. How many unknowns do I have? 4. Do I really want to try to solve this with substitution or elimination? Not really. It would take a while to do. It wouldn't be very pretty, would it? Okay. Likewise, is this something I can easily do by graphing? No. Heck, what does this even mean graph-wise?
It's 4-dimensional time.
I'm doing 4 dimensions. Okay. Basically, each of these equations represents a 3D space, and I'm looking to see where these 3D spaces intersect each other in 4 dimensions. Okay? That's what this represents. I don't know about you, but I have trouble enough drawing in 2 dimensions, let alone 4. Okay? So this is not something you can really do by graphing either. Okay? So we can either take forever doing elimination and substitution, or you can find a better way. And the better way is to solve using what's known as Cramer's rule. Cramer's rule. Okay? Now, Cramer's rule basically is a way to use determinants of a matrix to solve a multivariable equation like this. Okay? It's got basically there's 3 steps to it. The first step is to write a coefficient matrix based off of the system of equations. Okay? So, in my example up here, my coefficient matrix is going to be, I'm just going to look at the book to recopy it. It's going to be 1, -1, 2, -1, okay? 2, 1, 1, -1, okay? Then 1, 1, 0, -1, and then finally 1, 1, -2, 1, okay? Basically, each of these columns is going to be a variable. This is my x column, my y column, my z column, my w column. And I'm also going to go ahead and augment this matrix with an extra column on the end, which I'm just going to call my answers column. Now remember, when you augment a matrix, you're just adding a little information to it to help you solve it. Okay? That's generally what you're doing. Alright? You're helping things out. That's what augment generally means. Okay? Alright? So that's what I'm going to get there. This is the coefficient matrix. Okay? So basically the first column is just the coefficients of x, which were 1, 2, 1, 1. Y's coefficients, -1, 1, 1, 1. Z's coefficients, 2, 1. Then there was no z in the third one, so we got a 0. And then -2. And then finally W's coefficients. And then my answers. Okay? Now, that's step 1. Okay? Step 2 is to take the determinant of this matrix. Okay?
But where do you augment it? At the end of the answers, or what is that dotted line?
Oh, that's just to say I'm done with the augment. You can sometimes flip them around. Basically, all you're doing is you're separating it out, saying this is added stuff. You can do that any way you want to. Okay. Next thing we're going to do is we're going to take the determinant of this matrix.
What's the stuff that you augmented?
Answers. Basically,
Equals 0.
the equals part. Yep. Equals 0, equals 0, equals -1, equals 1. Okay? And we have that there because we're going to be using those numbers, okay, in our third step to basically be able to calculate out what x, y, z, and w are. Okay? But first we're going to take the determinant of this matrix. When you take a determinant of an augmented matrix, you take the determinant of the regular matrix and leave out the augment part. So just ignore the answers part. Just concentrate on this determinant here. I used a calculator to do this earlier. I would suggest using a calculator because this is 4x4. It's pretty big. You don't want to try to do it by hand. Just use the calculator. And it comes out the determinant was equal to -8. Okay, when I use my calculator to figure this out. All right? Any questions there?
But you don't use the augment
For
to...
finding the determinant, no. Basically, you would just, if you're calculating the determinant by hand, you would just do the determinant like you normally would. So, my setup here would be 1, 2, 1, 1, -1, 1, 1, 1, 2, 1, 0, -2, -1, -1, -1, 1. Okay? I would use, basically, I would just take this and do the determinant process to this.
I would augment the last two rows and do it by
Yeah,
hand.
just do it the usual way, okay? But what I'm telling you right now is, Cramer's rule works best if you're just using a calculator to help you get through the steps faster, okay? And using the calculator, I got the determinant was -8, okay? That's what the answer was there. Okay, now here's the final step, okay? We're going to solve for the variables by replacing the variables column okay, with the answers. The answers column. Then taking the determinant then dividing by the new determinant. Or then dividing by the original determinant. And I'm going to set this up so you get exactly, so you see exactly what's going on. Okay? So what this looks like here is x. It's going to be equal to the determinant of, now, the very first column in my matrix, the one that was 1, 2, 1, 1, I'm going to replace with the augmented column, basically that column with the answers on it. Okay? So it would be 0, 0, -1, 1. But then the rest of this matrix remains the same. So it's going to be -1, 1, 1, 1, 2, 1, 0, -2, and then -1, -1, -1, 1. Okay? I'm going to take the determinant of this matrix, and I'm going to divide it by the determinant of the coefficient matrix, which we figured out was -8. Okay? Alright, so we worked this out here, and I did this earlier today, and I believe the answer I got was 1/2, but let me just redo it anyway. What we got calculators for. Okay, edit. Okay, here we go. 0. This is nice that the calculator will save
So should you put it in as two different matrices?
yes.
It's very plain.
I'm sorry, this came out to be -2 over -8, which gives me that x is equal to 1/4. Is that right? Let me just double check. I thought I got something different there. 0, 0, 0, 0. And 1, 1, 1, 1, 2, 1, 0, -2. 1,